Hi, David Williams here. In this video, I want to talk about how to simplify Boolean algebra expressions using K-maps. Now, in another video, I showed you what K-maps are and how to use them, but in this video, I specifically want to show you how to go from a Boolean algebra expression to the simplified form of the Boolean algebra expression using K-maps. So here's a Boolean algebra expression that we want to simplify and an associated K-map that we want to fill in. Each one of the boxes in the K-maps is associated with a particular product term. And each one of the product terms up here is actually associated with one or more product terms or one or more boxes of the actual K-map here. Now it is possible to go directly from this Boolean algebra expression to the K-map if you're pretty familiar with what you're doing. But I think a better intermediate step is to use the Boolean algebra expression to fill in a truth table and then go from the truth table to the K-map. The reason for that is it's a little bit easier to understand and follow exactly what you're doing. So let's build up a truth table. Each one of these terms in the Boolean algebra expression must correspond to one or more of the boxes in this truth table. We have three inputs, A, B, and C. So if we have a three-input term like this one, for example, this corresponds directly to one of the boxes in the truth table, not A, B, or C. This corresponds to 0, 1, 1 for A, B, and C. So we can find that box in the truth table, and we'll have a 1 there. Not A, B, not C. That corresponds to 0, 1, 0, the 0, 1, 0 row in the truth table. So there will be a 1 there. The not A, not B, not C corresponds to 0, 0, 0. So that is this box in the truth table. Now going to the A, not B term. Anywhere where A is a 1 and B is a 0 will be a 1 in the truth table. So there will actually be two places, one where the C is a 0 and one where the C is a 1. So here A is a 1, B is a 0. So there'll be a 1 there. And the row above it, A is a 1, B is a 0. So there will be a 1 there. Finally, we have this one last term B, not B. So this is when B is equal to 0. Anywhere B is equal to 0 should be a 1. And look, we actually already have a few of those filled in. There's only one more here that we need to fill in to complete the truth table for this Boolean algebra expression. If you watch my videos on sum of products expressions, you'll watch the exact opposite process where we go from a truth table to a Boolean algebra expression. So now we're going from a Boolean algebra expression to a truth table. To complete the truth table, we'll have a 0 here and a 0 here. The next step is to fill in the Karnaugh map from the truth table. So remember each one of these boxes corresponds to a box in the truth table. So for example, this is the 0, 0, 0 box. A equals 0, B equals 0, and C equals 0. So we'll fill in whatever the output is in the output column in the appropriate box in the Karnaugh map. So 0, 0, 0 is a 1. 0, 0, 1 up here, you can see it's a 1. 0, 1, 0 is a 1. That's this box over here. 0, 1, 1 is also a 1. 1, 0, 0 is a 1. 1, 0, 1 is a 1. 1, 1, 0 is a 0. And 1, 1, 1 is a 0. The next step in using the Karnaugh map to simplify the Boolean algebra expression is to group all the min terms. We want to group them in groups that are power of 2 in size, so 1, 2, 4, 8. We want to try to make sure that the size is as big as possible, and we want to make sure that we're grouping all of the min terms. So here's a big box. This is as big as I can make one, a group of 4. I can also make a group of 2 here, and that will group all the min terms. But remember, I want to make as big a group as possible, and it is allowable to overlap groups. So I can make a group like that. Now we want to identify the value of the box. So for this particular box, this group of 4 here, what variables are constant within that box? So we can see that A is a 0 in this row and A is a 1 in this row. So A changes as we go from row to row. So A is not constant in this box. B is a 0 in this column and B is a 0 in this column. So B doesn't change within that box. So the term, one of the variables in this expression for the box is going to be not B. We see that C is a 0 here, C is a 1 there. So this particular grouping here is a not B grouping. Now, what about this big box here? Well, we can see it spans all the columns, so B and C are changing as we go from box to box. However, A stays the same and A is equal to 0. So that grouping is not A. And the last step is to take the values of each of the groupings and OR them together. So in this case, the simplification will be not A or not B. And there's the final answer. Now let's look at an example with 4 input variables, A, B, C, and D. Very similar process. What we want to do is find out what rows in the truth table will be 1s based on this expression. It's easy to figure this out for the terms that have 4 variables in the product. And so in this case, A, not B, C, D corresponds to 1, 0, 1, 1. So we find the 1, 0, 1, 1 row down here, and we have a 1 there. This term is 0, 0, 1, 1, so it corresponds to the 0, 0, 1, 1 row, which is right here. This term corresponds to the 1, 1, 1, 0 row, which is down here. And finally, the last 4 variable product term is the 1, 0, 1, 0 row. So that's right there. Then when we're looking at a 3 variable term, this we can look for in the truth table is the rows where B is equal to 0, C is equal to 0, and D is equal to 0. There's 2 of them. One where A is a 1 and one where A is a 0. So here we have 0, 0, 0 with A as a 0. That one will be a 1. And then down here we have B0, C0, D0 with A equals a 1. I think I said 1 up here, but A is a 0 up here, obviously. Then this term is where A is equal to 0 and B is equal to 0. And then C and D can be any value, it doesn't matter. So we only have to look for the columns where A is 0 and B is 0, and that's actually the first 4 rows here, A0, B0, A0, B0, A0, B0, A0, B0. So those first 4 rows are all 1s. We actually already have 1s in the first row and the 4th row, so we just need 1s in those 2. Now as a last step in filling in this truth table, we can just put 0s in the rest of these rows. Now that the truth table is filled in, it's an easy process from going the truth table to the K-map and then from the K-map to the simplest Boolean algebra expression. And I've already walked through step by step how to do that in a previous video. So I'll do it step by step here, but I won't map out exactly the steps that I'm doing. The basic idea when I'm going from the truth table to the K-map is that each one of the boxes here corresponds to one of the rows in the truth table. So this is the 0, 0, 0 row. This row down here would be the 1, 1, 1 row. So I can take each one of the row values and put it into the K-map. So 0, 0, 0 is 1, 0, 0, 0, 1 is 1, 0, 0, 1, 0 is 1, 0, 0, 1, 1 is 1. The next 4 are all zeros, so then that corresponds to this particular row. Then 1, 0, 0, 0 is 1. That's the bottom row in the Karnaugh map. 1, 0, 0, 1 is 0. 1, 0, 1, 1 is a 1. And 1, 0, 1, 0 is also a 1. 1, 1, 0, 0 is 0. 1, 1, 0, 1 is 0. 1, 1, 1, 0 is a 1. It's this box over here. And the last row, 1, 1, 1, 1 is a 0. Next, I want to group the min terms. I want to group them in as big a group as possible, and I want to make sure I get all of the min terms. So here's a group of 4. I also want to make sure that the size of each group is a power of 2. There's a group of 4. It's the biggest power of 2 group that I can create. Another group I can make is going to involve these 2 cells. Now I could group those 2 cells, but this row here is actually adjacent to this row up here. So I can make, instead of having a group of 2, I can make a group of 4 that's using these 2 cells combined with those top 2 cells. That will help ensure that the expression that I end up with is in its simplest form. I'm also going to need to make a group with this cell here. And unfortunately, the simplest that I can do is a group of 2 like that. I can't extend up to this cell at the top because that would only make a group of 3, not a group of 4. Finally, I need to group this cell. Now it looks like I could wrap around this cell to group it with this cell over here, or this cell to group it up with this cell up here, but actually, if I look at all four corners, those four corners are all ones, and that will actually make a group of 4 from the four corners. So that cell is grouped with that cell, is grouped with that cell, is grouped with that cell to make one single group of 4 using the four corners. It might not seem so obvious, but if I don't do this, then I won't end up with the simplest expression at the end, and I would actually be able to do some Boolean algebra on it to make the expression even simpler. The last step is to come up with an expression for each 4 of these cells and then combine the cells into the final expression. So let's look at first at the red cell here. This is the row where A is equal to 0, B is equal to 0. C and D are changing as I move from column to column, so they won't be in the expression. So that cell there, it will be not A, not B, because both A and B are 0 for that. Then let's look at this green grouping here. As I move from column to column, C is a 1, C is a 1, so C doesn't change, while D is a 1, D is a 0, D does change. So that grouping there will have C, because C is equal to 1. I'm looking at the two different rows. We see A0, B0, A1, B0. A changes from a 0 to a 1. B doesn't change. It's a 0 there and a 0 there. So we'll have not B as part of the expression there. Thirdly, I have this grouping right here. In that group, we see that A is a 1 for both of those rows. So A will be in part of the expression, and it will be just A. And then the grouping is in a single column where C is equal to 1, D is equal to 0. So C, not D, will be the expression for that grouping. Finally, the four corner grouping. What happens in these four corners? Well, we see there all the bits are 0 here. If we move over to this one, we see that C changed from a 0 to a 1. So C won't be in the expression. D is a 0 in both, so D is going to be part of the, well, D is potentially part of the expression. It's the same column for the bottom two cells, so D is not changing. D is equal to 0, so D will be part of that group. D is equal to 0, so it's not D. Now looking at the rows that this four corner grouping is in, A is 0 for this row, A is 1 for that row, so A is changing. A won't be part of it. B is 0 for this row, B is 0 for that row, so B stays the same, and it will be not B. Now I can combine these four product terms together. Not B, not D, ORed with not A, not B, ORed with not B, C, ORed with A, C, not D. And that's the simplest expression that I can have for this beginning expression, and I didn't have to do any Boolean algebra to get there. So I hope you learned a little bit in this video, and I'll see you in the next one.